Hello everyone! In this video, we will be covering 3 different experiments to illustrate how physics concepts can be applied to our daily lives. For this experiment, we will be needing a string, a magnet, and an empty drink can. So how exactly does this experiment work? The very first step is to set the magnet pendulum to oscillate. You will now observe that the empty drink can begins to oscillate as well. But why is this so? First, let's take a look at the definition of eddy currents. Eddy currents flow in closed loops within conductors in planes perpendicular to the magnetic field. It can be induced in an electrically conductive material if a magnet is placed close to it. Let's visualize this concept of eddy currents through a diagram. With a better idea of what eddy currents are all about, let's move on back to the experiment. The drinking can made of aluminium is an electrical conductor. The oscillating magnet pendulum generates an oscillating magnetic field. The induced EMF causes eddy currents to flow in the can. This causes the drink can to undergo an oscillating motion. However, the experiment is only possible if the magnet is placed near the drinking can and if the material is an electrical conductor.
Hi, in this experiment, I'll be using a swimming pool to illustrate how waves from two sources interfere. Two dippers will be attached to me, and I'll act as a coherent source sending out 2 sets of circular ripples. I'm a coherent source as the wave produced by are of constant phase difference, meaning that wave fronts differ by a fixed amount.
And so, to study whether 2 waves meeting at a point undergo constructive or destructive interference, the path difference between the 2 sources is calculated. Let us start by examining what path difference exactly is. Path difference is the difference between the distances each wave travels to point P from sources S1 and S2 respectively. With this concept in mind, let's move ahead to the experiment. In this experiment, the 2 red dippers, as you can see, act as 2 coherent sources. If S1 and S2 are in phase, when S1A and S2A differ by integer multiple of wavelength, the phase difference of wave at S1 is equal to the phase difference of wave at S2. Therefore, waves arriving at A are in phase. When 2 waves from coherent sources arrive at point A in phase, they superpose to produce a resultant wave with the largest amplitude and maximum. This is called a constructive interference. In contrast, when S1b and S2b differ by half an integer multiple of wavelength, there is additional phase difference of pi radian between the 2 waves arriving at B. Therefore, waves arriving at B are antiphase. When 2 waves from coherent sources arrive at point B antiphase, they superpose to produce a resultant wave with minimum amplitude. This is called a destructive interference. The third concept illustrating electromagnetic induction will require an aluminium pipe, a plastic object, and a magnet. To start off, we will first be dropping the yellow plastic object down the pipe. Close attention should be observed on the stopwatch to record the time taken. Now, we will be dropping the magnet down the pipe. You would have noticed that the magnet takes a longer time to move down the pipe. But why is this so? To illustrate this, we will be using a series of diagrams and explanations. It is important to understand the definition of Lenz's law before we begin explaining. The Lenz's law states that the direction of the induced EMF is such that it may produce an effect that opposes the change causing it. When the north pole of the magnet moves down the aluminium pipe, the flux linkage through the pipe increases with time. This increasing flux induces an EMF in the pipe, producing an induced current. The induced current produces its own magnetic field, inducing a north pole on the top of the pipe and repels the magnet as it enters the pipe. When the south pole of the magnet leaves the pipe, the flux linkage through the pipe decreases with time. This decreasing flux induces an EMF in the pipe, inducing a north pole at the bottom of the pipe. This attracts the magnet as it leaves the pipe. So this sums up the 3 main concepts that we have in this video. We hope that you have learned something new from it.